went ahead and updated our free body diagram. And I just want to remind you that AB is affecting both joint A and joint B equally. So AB and BC are combining to hold up joint B when BD is pulling it down. And I also want to point out that if you notice, we calculated DC and AD, and we got the exact same number. Well, and you might say, well, no, they're off by a decimal. That was probably just a rounding error when we rounded our decimals, or when we rounded our hypotenuse, or in either one. But in reality, this is positive 263 pounds. And this is positive 263 pounds. It was just probably a rounding error. And of course, joint D is canceled out left and right. It has to be. Otherwise, it'd be being pulled left or right, and the bridge would be falling apart. And the only force we really have left is this force of gravity D, which is 500 pounds. It has to be. It's being pulled upward, as we said earlier, 500 pounds at joint D, and joint B is being pulled down with a force of 500 pounds. And of course it is. It has to be. Because all of our forces have to cancel out in every direction at every joint. The sum of all forces at all joints has to equal 0. And one more quick note, if you're getting a different answer over here, a way off answer at DC, for example, than you got at AD, then you probably did something wrong. And if you're getting a force that's like 2,000 pounds when your original gravity was, or your original force is 500 pounds, how could the forces on our bridge be greater than our original force of gravity D? So it would make sense that these forces would be smaller than 500, but it shouldn't be too small, so we couldn't get some random 2,068 pounds, and we couldn't get some random 10 pounds most likely. It'd be very unlikely that 10 pounds would happen on any of these bridges, or any of these members. So both of these would probably be impossible. It's a good way to double check your answer. Does it make logical sense? But that's how you calculate truss forces.